Hello, this is sort of the final summary of the most complicated two-variable example we could get using solving it using expectation algebra. So in this case, we're going to look at a z which is made up of a combination of two variables, x and y, and their linear multipliers. And I've also put in the plus and minus here. Just so that we can think about, you can see what the effect is of it being plus or minus. So first thing we do, here's our e to the if z equals that, then e to the z equals e to the expected value. The expected value of z is the expected value of ax plus or minus by. And if we then convert that into a probability statement, well, it's the sum over a number of i's and j's of all the x's and all the y's in this. This is our overall variable, ax plus by, multiplied. It's a weighted average, and we're multiplying it by the probabilities, and then we're summing them up. And again, we're assuming that these two variables x and y are independent, which means we can rewrite this probability as a probability of xi times the probability of yj. And then we're going to sum that over all xi's and all yj's, all x's and y's. Yeah. So here it is, written in that form with this as the probability, and we can see they're all multiplied together here. So again, here I've got two terms inside my bracket, so I can split those out, and I can have a term here based on axi, and I can have another term here doing the summations for bj, so byj on the other side. Okay, and these are sums over both I and j again. Now if we look at this first term, here we've got our a, which of course is a constant, and we can move that out to the front. Then we've got all the terms of relating to xi, so we can put those together. Here it is. So we've got the sum of xi times p of xi, and then we bring the y terms together, the yj terms together, and of course we're doing a multiplication because effectively, as we looked at before, we've got a whole series here, and we're multiplying this direction by that direction. So if we look at what we've got here, well, this first term, we've got an a at the front here. That's an expected value of x, isn't it? X times p of x all summed, and then the sum of all the py's will just be 1. So that's our first term. Our second term, well, again, this is based on our by. Let's take that out. There's our byj. There's our byj. Again, the b is constant for the summation, so that can come out the front. And then we can split the terms here. So we've got our terms that entirely relate to px, probably xi. So that's there's sum of all of those. And then we've got the yj and the pyj here coming into this, and again we're multiplying them together, so we got one side by another, as we saw in our table example. So here we've got looking at this term, bring it down, we get a b at the front, the sum of all the probabilities of x, well, that's going to be 1, and the y times the py is going to be the expected value of y. So therefore the expected value of ax plus by is a times, that should be plus or minus, shouldn't it? Apologies. Is going to be equal to a times the expected value of x plus or minus b times the expected value of y. Yeah, now that makes sense because that's just an extension of what we saw in the other videos where we just did it with no a and b's. Okay, let's have a look at the variance. Well, to find the variance, we first have to find e to the z squared, and so that becomes our variable in the bracket. There are ax plus or minus by, they're all squared, and then we've got our two probabilities on the end. Then again we can expand this bracket here. Now we've got three terms, a squared x squared, ab xy, and then b squared y squared. If we split those up into three separate terms and do the summation separately, Then our first term, we've got our ax squared, so we can bring our a squared out the front. Then we've got our xi squared, probability of xi times our py j, and that's summed across both. And then of course we can split that up, so we can take all our terms for the x into one sum, and all the terms, the parts relating to yj into the other. So we know that this first one here is a squared, you've got the a squared out the front, this is e to the x squared in the bracket, and this one here is just going to be 1. If we go to the other end of this example, I'm just going to look at the other end quickly. Here was our b squared y squared. Well, if we take that off into our third term, the b squared comes out the front because it's a constant for the whole of these summations. And we've got the y squared, that's yj squared. Then we've got our probability of xi and our probability of yj. And then if we group that up again, the terms, we've got our b squared out the front, we've got our probability of xi and the sum of those, and then we multiply by the sum of our probabilities of yj squared pj. So this term, this element in the middle is 1, and this element at the right hand end is the expected value of y squared. Here we go. And we've also got in the middle this other term here, which is the AB, e to the ABXJ. So the 2AB can come out the front. And then we've got our, bring our x terms together, we've got xpx, and then we've got our ypy. So therefore, the first one of these is expected value of x, and the second one is expected value of y. And therefore we get to this expression, e to the z squared, with our a squared expected value of x squared, our plus or minus in the middle, and then it's a plus again for the b squared, isn't it? Because minus and minuses times and minuses are positive. So if we then take those into the calculate our variance, our orange numbers here are the z squared, and then we've got to take the e to the z all squared, expected value of z all squared. So we've got a squared, and if we already know that is a e to the x and b plus or minus b e to the y. So we already know that, and of course that's squared, so we expand that bracket, we get this, we get these three terms. And if we then rearrange those terms at the front end here, I've got this term here, a squared e to the x squared, and then if I take the first term of the green terms, that goes there, then I've got my a squared, which is a factor, bring that out the front, for e to the x all squared, okay, which we recognize here as being the variance of x. We can see that. Then if we look at the right hand terms, here we've got the b squared e to the y squared, e expectation of y squared, and here we've got the b squared expectation of y all squared. That's a subtraction, so if we put those two terms together, here we go there, we can say we've got b squared times the variance of y. And what happens with these other two terms? Well, I've got an expectation term here, 2ab expected x times expected y, and then I've got a subtraction of exactly the same. So those two are going to cancel out. And therefore, in very general terms, for independent variables here, the expected variance of ax plus by will equal a squared times the variance of x plus b squared times the variance of y. So that's where we get to. So here's a more generalized answer to what we've been looking at, and that would give us this quick summary page, these two results up here at the top for two independent variables. These expectation and variance equalities will always hold. I hope that's of use.